guys, welcome back to chapter 11. Today we're going to talk about solubility and just some properties that we observe about solubility. So how can we change the solubility of a substance? Can we increase it? Can we decrease it? And what are some ways that we can do that? So properties that affect solubility. We're going to look at two different properties. The first property we're going to look at is temperature. What happens if we increase or decrease? And we're going to look at how temperature affects a solid that's dissolved in solution. We're also going to look at how temperature affects a gas that's dissolved in solution. And then we're going to look at pressure. So how does pressure affect solubility? But for that one, we're just going to look at gases. So here's our first one, the solubility of a solid and temperature. So looking at this graph, along the bottom, we see temperatures increasing as we go from left to right. And along the side, going bottom to top, we see solubility is increasing. So let me talk about what this solubility means. So this is the number of grams of solute that's going to dissolve per 100 grams of water. So for example, this is sugar right here. If we look at temperature equals 0, we could put 180 grams of sugar into 100 grams of water. So that's what that means on this side. Now, if we look at this graph for this table as a whole, what we're going to see is a lot of positive slopes, right? So the slopes are going up. Even if it's just a gentle increase, there is still an increase among most of the slopes. We'll ignore this guy down here. So what that tells us is, generally speaking, as we increase the temperature, solubility of a solid is going to go up. We know this to be true because we live in the South and we make sweet tea, right? So we make sweet tea at roughly room temperature, so that's somewhere around here. If we want more sugar to be dissolved in that sweet tea, we tend to heat up our tea, and what we'll see is more of that sugar will dissolve. Heat it up again, more sugar will dissolve. So we see this direct proportionality. Increase the temperature, increase the solubility of a solid. I find it kind of unique down here. So we look at sodium chloride. It does have a positive slope. It's ever so slight. So I always think about like putting salt into my water as I'm cooking. I'm like, oh yeah, I can get more salt in there if I heat up the solution. But it's actually just the slightest little increase where we see other things are very dramatic, like sugar. All right, so now we're going to talk about the solubility of a gas with temperature. So speaking of cooking, have you ever put a pot of water onto the stove and you're like waiting for it to boil, right? Right before that pot of water hits a rolling boil, you start to see these kind of little bubbles form on the bottom. My kids always ask me, Mommy, is it boiling? Like, no, that's not boiling yet. But have you ever considered what are those bubbles that form on the bottom of our pans? So what that is it's the nitrogen and oxygen gases that are trapped in the water. As we heat up that water, those nitrogen and oxygen gases come crashing out of solution, or they come falling out of solution. So as we increase the temperature of our liquid, what we find is the solubility of that gas decreases. So it's this inverse proportionality. So if I increase the temperature, I decrease the solubility of that gas. Okay. So what we observe as we're putting that pot on the stove, we observe that nitrogen and oxygen that are crashing out of solution, right? So it can no longer hold as much gas as it wanted to, and now those are coming out of solution. Another example of this solubility of gas and temperature, if you've ever worked in the restaurant industry. So if you think about your soda tap lines, or if you think about your beer tap lines, do you typically keep those tap lines cold, or do you keep those tap lines like warm or at room temperature? Well, typically those tap lines are kept cold, right? So that has to do with this solubility of gas and temperature. If I keep the tap lines cold, that those gas particles, that carbon dioxide that's dissolved in those sodas, will stay dissolved in the soda. So this would be an example of pouring a cold soda or cold beer off the tap. If we kept those tap lines warm, what we would see is as we start to pour that drink, that carbon dioxide would come crashing out or bubbling out of solution, and we'd see a whole lot of bubbles on the top of our drinks, and that would be really annoying to pour. So that's why we keep our tap lines cold. It has to do with the solubility of gas and temperature. And then for my mathematically inclined students, we see that same kind of graph. So temperature increases left to right. Solubility of a gas increases from top to bottom. And what we see is a bunch of negative slopes. So as we increase the temperature, solubility of a gas goes down. Now we're going to transition over to the other property. We're going to look at how pressure affects the solubility of a gas. So now we're looking at pressure and gas. So the best example of this would be any of the drinks that are carbonated that you may drink, right? So if you think about opening up a can of soda, or think about opening up a 2-liter bottle of soda, okay? If you were to, let's say, shake it up, or even just leave it regular, not even shake it up, as soon as you open that seal, when you open that seal, what you are doing is you are decreasing the pressure. So that was a pressurized system, whether it's a 2-liter or a can of soda. And as soon as you open up that can, it opens it up to the pressure that's just kind of around it, and it automatically decreases the pressure of that container. And what we see when we open our can of soda, or we open our 2-liter bottle of soda, all of a sudden we see a whole bunch of bubbles start forming, right? Those bubbles come kind of all reach the top, and if we shake it up, they'll come shooting out of the top, right? So what that is that is the gas that's crashing or bubbling out of solution. So as we decrease the pressure, we're also decreasing the solubility of that gas. So when it was pressurized, all of that carbon dioxide was dissolved in solution, and as soon as we decrease the pressure, that carbon dioxide comes bubbling out. So here's a graphic kind of depicting the same thing. I really like this graphic because you can kind of peek inside the can. So here's our pressurized system. So it's under pressure, and the carbon dioxide is dissolved in solution. So it's not bubbles, like it would just look uniform throughout. And as soon as we decrease the pressure by opening that can, so pressure is released, we see that the carbon dioxide comes bubbling out of solution. So it can no longer be dissolved, and it comes out in the form of a bubble. So that is just some properties that affect solubility of solids, affect solubility of gases. I hope you guys found this helpful.